All right, so polynomials, dividing them, day 2, synthetic division. When you hear the word synthetic, a lot of us think fake, and that's exactly what we're going to be doing. We're going to be fake dividing. So we're going to take 7x cubed minus 6x plus 9. We're going to divide it by x plus 5. And you know how much work that was yesterday when we did the long division and everything else? Well, we're going to do things a little differently. We're going to take what we're dividing by our divisor, and we're going to use that zero product property and solve it for the x. Now notice the coefficient in front of the x has to be 1 to be able to use synthetic. If you have a variable here, it doesn't always work so well. Okay, we have to have that being as a 1. So x plus 5 equals 0. That means x is negative 5. When this is just a 1, we just look at this number here and use the opposite sign. It's going to go over here on the left in a box. And we're going to use the coefficients of each of the terms. Now notice you don't see a 0 coefficient up here. But we are missing our x squared value, so the coefficient would be 0. All right, so this is kind of a little fun game. And we're going to leave a space underneath, and we're going to draw a line. The first term drops straight down. So it drops down as a 7. And then we're going to do a series of multiplying and adding or subtracting. So negative 5 times 7, that's a negative 35. And I write it underneath the next term. And I add them. 0 plus negative 35, negative 35. And then I'm going to multiply negative 35 times that negative 5. So these two values are going to get multiplied, and the answer is going to get written here. Okay, so that becomes, let's see, that's 25, 175. And it's positive because negative times a negative. But that's plus a negative 6. So I'm adding straight down. These two values get added together. So that's a 169. Oops, and it's a positive, not negative. And I'm going to multiply that times negative 5. When I multiply negative 5 times 169, I get a negative 845. And then, of course, I'm going to add straight down and get these two, and that's a negative 836. This is my remainder. This is my answer, but we need to write it back so it looks right. Now, if you noticed, in all the ones that we did on synthetic division, each of these in our answer started with 1 power less than what was here. So this is an x cubed. That means this has to be 1 power less, so it's an x squared. So it's 7x squared minus 35x plus 169 plus a remainder of negative 836 over x plus 5. And much easier, much shorter, not as time consuming. It does take a little bit to get used to, but I promise this is way faster and simpler than what we were doing. So we're going to look at another example, number 2 right here. 4x to the 4th minus 3x squared plus 7x plus 2, and we're going to divide it by x minus 1. So first things first, I need to use the zero product property. X minus 1/2 equals 0. That means x is equal to 1/2. And that's the value that's going to go in my box. That's what everything is going to get multiplied by. And I need to write my coefficients. 4. I have no cubes, so I need to leave a space saver 0. Negative 3, 7, and 2. All the coefficients are accounted for. Leave some space, draw my line, drop my first term straight down. And then 1/2 times 4. Well, half of 4 is 2. And I add. So remember, these are being multiplied. Answer goes there. And then you add those two together. So 0 plus 2 is 2. What's half of 2? Ah, that's 1. And I'm going to add these together. So negative 3 plus 1 is negative 2. And then I go half of negative 2 is negative 1. 7 plus negative 1 is 6. 1/2 of 6 is 3. 2 plus 3 is 5. This is my remainder. Okay? And I rewrite it out as a polynomial. I start with 1 power less, so it's going to be 4x to the 3rd, because that's a 4th, plus 2x squared, and it just follows down, minus 2x plus 6 plus 5 over what I was dividing by x minus 1/2. And there's your answer. Easy peasy. All right. We'll practice some of those in class. We want to talk about the remainder theorem to determine if a binomial is a factor of the polynomial and if we can continue factoring it. It does help us a lot using factoring. So if I want to quickly decide if that's a factor of this polynomial, I can use synthetic division to do so. And it just makes life so much easier. So x plus 3 equals 0. That means x is negative 3. Negative 3 goes in the box. I write out my coefficients, 1, 3, negative 4, and negative 12. Leave some space. Draw my line. And I'm going to check. Now, if I get a remainder of 0, it means that x plus 3 is a factor. If I get a remainder of anything other than 0, it's not a factor. So we're going to drop our 1 down. Negative 3 times 1 is negative 3. And I add 3 plus negative 3 is 0. Negative 3 times 0 is 0. Negative 4 plus 0 is negative 4. Negative 3 times negative 4 is 12. And I get negative 12 plus 12 is 0. So I have a 0 remainder. Remember, this last one here, this is my remainder. So that means that x plus 3 is a factor. And I can continue to find the remaining factors. This is how you do that. So I have to rewrite this as a term. This is an x squared because it's 1 less than the cube, so this is x squared. I have 0 x's minus 4. Well, that's x squared minus 4. I can factor that. That's simply x minus 2 times x plus 2 because my middle terms have to drop out. Now, I cannot forget about this factor up here, the x plus 3 that they gave me. This is the factored form of that polynomial. So we're going to look at one more. It just makes it so much easier because I don't want to sit and waste a whole lot of time trying to factor something if it cannot factor. So let's look at this real quick. We're going to check this one. So the number that goes in the box is what x equals when we use that zero product property. I have a squared missing, so I need to account for it. 0, negative 2, and a 5. And I'm going to check. If I get a remainder of 0, it's a factor, and I can continue factoring. If it's not a remainder of 0, I can stop because I can't factor no more. Negative 1 times 3, or excuse me, that comes down. So negative 1 times 3 is a negative 3. 0 plus negative 3 is negative 3. Negative 1 times negative 3 is a positive 3. And I get a 1. Negative 1 times 1 is negative 1. And I get a remainder of 4. So this tells me x plus 1 is not a factor of p of x, my function. And since it's not a factor, I can't continue to factor it. But that's so much easier than trying to play that guess and check and do grouping and all that other fun stuff. Take good notes.